Good morning, everyone. Today we're going to be talking about chords. As you recall, a chord is a segment that connects any 2 points on a circle. So for example, AB is a chord and BC is a chord. Okay? These chords have several important properties and we are going to look at 5 of them today. So property number 1. If we have 2 chords that are equal in length on the same circle, so if they are congruent, then the corresponding central angles will also be congruent. So here, if chord AB is congruent to chord CD, angle AOB is congruent to angle COD. Okay? Property number 2. If 2 chords are congruent, then the corresponding arcs are also congruent. So those 2 arcs, AB and CD, have equal measure and equal length. Okay? Which I think follows from this statement because we know those central angles were the same. So if the central angles are the same, that means the arcs have to be the same. Okay? Property number 3, and this one probably is used the most frequently, is that if 2 chords in the same circle are the same distance away from the center of the circle, then those two chords have to be congruent. So here, because EO is the same as OF, it follows that the chord AB is congruent to chord CD. And remember, the distance for any point from the line is the segment that is perpendicular to the line, right? So we have to find the shortest segment, okay? Property number 4. If a diameter of a circle, so like over here CD, is perpendicular to a chord, then it bisects that chord, okay? So if diameter is perpendicular to any chord, so any chord that will go through this diameter and is perpendicular to diameter will be bisected by this diameter. And finally, if we create or construct a perpendicular bisector of a chord, that perpendicular bisector will always contain diameter and thus will also contain the center of the circle. So it's a really good property that can be used to find the center of any circle. All we have to do is construct a chord, or construct 2 chords that are not parallel to each other, do perpendicular bisector of each chord, and wherever those 2 perpendicular bisectors intersect will be the center of our circle. And finally, it's really important to know that for all of these theorems, the converse is also true. So all of these can be rewritten as biconditional statements. All right, that's all for today.